what we recommend, or what I've been recommending to customers, is, unless most seasoned administrators are not going to let something loose without having at least a reasonable understanding of what it's going to do to their established infrastructure, right?
Mm-hmm.
So the question is, how do I evaluate on my infrastructure how FRA is going to impact it now that I have 3800s up? The answer is slide 3.
Okay. You want me to go through slide 3, or you want to go through all the best practice recommendations?
Well, I can go through the best practice recommendations first. Okay, so first thing is putting FRA in static mode on the APs and globally enabled. What this is going to produce is it's going to give you the coverage overlap factor for each 3800, 2800 that you have deployed, and it's going to do that passively without changing the role of the AP. So in other words, if you're deploying 2.4 and 5 gigahertz today, you put in 3800s, now you want to, start playing with this FRA, do it safely first. Take the APs out of auto mode. There is a command at the command line to do this. And then you can look at the results of what FRA thinks of your infrastructure before you commit to making changes. Highly recommend that. FRA sensitivity, high, 90%. Why? It's been very conservative. FRA is extremely conservative by nature, and we've had people that leave it set to low, which is 100% coverage, and then they get, a bunch of 92s, 98s. In our experience, there's use cases where even 75% coverage may be well enough. For instance, an AP on an outside wall that you're only using 50% of the circle, you can probably flip that to dual 5 gigahertz if it's 75% covered. FRA interval, this one gets a little confusing for folks sometimes. It has to be equal to or greater than the DCA interval. The minimum is 1 hour. So if they're using a DCA timer for every 8 hours, the minimum FRA interval is going to be every 8 hours. Now, it's not incredibly important to run FRA every single hour. The reason for that is because FRA is going to establish what interfaces are redundant. We're going to put them into service, right? And then after that, FRA really shouldn't change that much. So a couple of conditions that can come up for you are, one, you see a coverage hole in 2.4 on one of the APs that is contributing to the redundancy of a dual 5 gigahertz cell. Meaning I've got 3 APs that I counted on for covering my 2.4 of that cell. One of them experiences a coverage hole. That will revert the AP back to 2.4 gigahertz to fill in that coverage hole.
Got it.
The other condition for FRA running is if, for instance, you switch to 80 megahertz bandwidth, and we've seen this in DBS, it may be that you were okay running dual 5 gigahertz with 40 megahertz channels, but when it flips to 80 megahertz bandwidth on one of the other interfaces, there is no longer room to run dual 5 gigahertz interfaces because of that 100 megahertz separation requirement. In that case, the AP is going to be flipped over to a monitor mode, and then it will be evaluated at each FRA run for how long it's been in monitor mode and whether or not there is now room to move it back to 5 gigahertz. So if your FRA interval is set to 8 hours, it's going to be 8 hours before we evaluate that. Make sense?
So the recommendation is about an hour or so.
Yeah, an hour, and I would leave DCA at 10 minutes unless there is a very good reason why you've changed that.
Got it.
All right. Client network preference at default. What this says is that it prevents an FRA radio, an XOR radio, from changing roles if there's 3 or more clients already on the 2.4 gigahertz radio. Now, this is good in a production environment, but you may want to override it in a lab environment to the connectivity profile. The connectivity profile will allow an immediate change regardless of the number of clients on 2.4. So we recommend default. Neighbor discovery packet factor. This is a very, very important piece. All right. neighbor relations is extremely important to FRA. Okay, and there was some changes done to the default pruning timer or retention value for NDP messages that we hear. That was done in 8.0. In 8.1, we have the ability to change that to increase the timer. There you go. In 8.0 MR4, which is not a factor for this build, but what we have found is changing the NDP factor to 20 increases the saturation and the stability of neighbor messages. The default, being 5 now, says we're only holding on to those messages for 15 minutes. Highly advise anybody who's going to turn on FRA to, prior to that, at least an hour before that, changing that NDP factor to the default, from the default to a factor of 20. And that will ensure stable neighbor relations and a good FRA run. And lastly, very, very, very prudent. DCA, of course, over time can settle in with some less than optimized changes. Highly recommend running a DCA recalibration on the first run of FRA. What that's going to do is it's going to run FRA every 10 minutes, followed immediately by DCA running every 10 minutes. DCA is going to optimize channel assignments, and FRA is going to get better.
So is there any configuration for this?
Yeah, that's in the slide.
Okay, let's go through the rest.
Yep, so go to the first slide with the detail after this. All right. Here's the config advanced FRA revert all to static command. What that does is it puts all of the APs in manual mode, FRA enabled, so that you can calculate the coverage overlap factor. Then under monitor dual band radios, you can see the coverage overlap factor that's being assigned, and you can identify individual radios. The full command is at the bottom of the slide here. So your options are config advanced FRA revert. All implies all XOR radios. Auto implies only the ones that are in auto. Then the second input is whether you want those radios to be static or auto.
Got it.
Okay. Next slide. This is showing what the radio role assignment, just to clarify that, is. And under radio role assignment, you can have auto, meaning that it is available. And go ahead and click your, I think this is a build out slide. You might want to get rid of the builds. Yeah, auto default makes the radio available to FRA. Manual takes the radio out of global FRA assignment, meaning FRA is still running. It just doesn't have the right to assign this radio. Being in client serving 2.4 gigahertz puts that interface in the FRA calculation. If you put that to 5 gigahertz, there is nothing. It's no longer part of the FRA calculation for redundant radios. Make sense?
Yes, absolutely, because we are talking about mainly managing the 2.4 gig only, right? So
precisely,
how much of already 2.4 coverage you want or there, and then calculate on the basis of it that do we need enough of radios on 2.4, can we turn them off? So absolutely the client serving has to be 2.4 because the whole algorithm is to see how much of 2.4 energy is there and make sure that we can turn off certain 2.4 radios, etc. Right?
Absolutely correct. Once it's been assigned a role, it's the domain of DCA to decide whether it's good in that role or whether it should be in a monitor mode. And the priority is always going to make dual 5 gigahertz first and then monitor mode if we can't fit that.
Perfect.
Okay, perfect. Next slide. All right, go ahead, and this is a build-out slide too. But your controls of the configuration, and you might want to just skip to this last slide if you're not doing the builds. But this is showing flexible radio assignment at the controller on the GUI. First enabled, sensitivity by default is low. We're saying make that high and leave the interval at 1 hour.
So the default is going to come as low, but you're recommending it to make it high as the best practices, right?
I am. For this stage, for the evaluation point, unless you're making active changes, it can be set to whatever it is. In production, we're recommending high. We found that high gives us a good saturation. We have good coverage at 2.4. We validated that at Georgia Tech and other locations. In some cases, you may want to go back to low or even override some of the assignments because of high density requirements. But that's an advanced subject, and you really have to know what you're doing there.
Got it. Okay.
All right.
What do we have over here?
Yeah, this covers the client network preference, which is a new command in 8.2. And this basically is a personality update for DCA. The default is no change from current DCA behavior, from current TPC behavior, from current DBS behavior, or DFS EDRM behavior. However, FRA defaults to the connectivity profile. The connectivity profile puts a bias on keeping clients connected, doing less changes, being less sensitive. You follow me? So this automatically puts DCA into a higher bias on the current channel, meaning we tend to want to stick to the channel rather than move for temporary things. Definitely prefer current channel when voice and video are involved, and lower the sensitivity for DCA. Now, you can override this in DCA. Just setting this command, if you only want DCA to still run a medium, you can go to the GUI on DCA and select medium, and it will override that part of the connectivity profile. DTPC should not reduce power when weak signal clients detected, so its focus is on continuing to keep everybody connected. DBS, again, less volatility there. It wants to put lower bias on the client type, meaning it's not as prone to changing. Flex DFS, EDRM, priority on maintaining current channel, voice video client, increased contribution. And then no band roll switching when more than 3 clients exist. That's the production mode, saying if we determine that interface is redundant, then FRA or DCA would wait until that interface had less than 3 clients to make that change on a DCA interval. Does that make sense?
Yes, it makes sense. So this is one of the other best practices. What would you recommend along with the FRA with the previous configurations which you have shown, right?
Absolutely. This is the default profile is the best for an unknown environment. In other words, a production environment until you get a real handle on what FRA is going to do. If you go to the throughput, profile, note that regardless of how many users you have on 2.4 gigahertz, it's going to flip to 5 gigahertz, which is not the end of the world, by the way, because most of the 2.4 gigahertz clients in most environments are going to be dual band capable, and they're going to reattach to the same 5 gigahertz cell. It's just not going to be without disruption. But it should be a very, very low disruption, and administrators have to evaluate that. All right, you want to go to the next slide? This covers the Neighbor Discovery Protocol resolution and the NDP timer. New command introduced in 8.1 is the NBP, or the Neighbor Timeout Factor. By default, up through 8.0, this was 1 hour. The reason for this is that NDP is very much a probability argument. We don't have free reign to transmit in DFS channels, so we tend to have less resolution there. What tends to happen in a busy environment is that NDP gets missed, or it gets collided, or it's not received due to RF conditions. In that case, you've got no option but to extend the buffer or for how long we consider a neighbor valid, right? The downside to that is particularly where you'll see it is in prime. If you have a predictive heat map, prime is going to hold that predictive heat map for that AP until it times out of the NDP pruning timer. So that's why it was moved back to 15 minutes. Interesting to note, in 8.2 MR4 and beyond, this is going to be returned to the default value of 1 hour. It has actually caused quite a bit of instability to go to 15 minutes. So a factor of 20 restores the legacy function. That's our recommendation to run. And it was fine for everybody all the way through 8.0, by the way.
Okay.
Next
so
slide.
in 8.2 MR4, you expect this to revert back to 1 hour, right?
I'm assuming they're going to put it into the MR. I know for a fact it's the decision in 8.4.
Okay, got it.
Okay, and then in DCA recalibration, this is what we used to call restart. However, I'm calling it a calibration now because that's a nicer name. So sure. DCA startup mode enables an aggressive channel search, removes customer configured hysteresis, in other words, ignores sensitivity. We have another buffering factor called NCF check that ensures that a change is not disruptive for a group of neighborhood APs. In other words, APs that can hear one another. If you make a channel change, they should all stay the same or get better. That check's removed. Lower internal dampening. There's several things that we do to make us not twitchy. That's removed while we do a startup mode. And it's much more than simply changing sensitivity to high on DCA. 7.6 and before, DCA entered startup mode on a reboot of the RF group leader. So anytime you rebooted that RF group leader, you automatically did a DCA restart. Above that, they have changed the behavior. 8.0 and forward, it's only invoked on a reboot if there's been a code upgrade. So this is important to get out there because a lot of people assume when they reboot, if they have an 8540 or 5520 as their single controller, there's no concern about who the RF group leader is, right?
Yes.
They assume that if they've rebooted the controller, they're doing the DCA restart, and that's not the case. By the way, this is also the deck that I showed to Greg where we're talking about automating the DCA restart.
Yep.
That's got some traction. We're going to be working that into a proposal and getting it into 8.4 because this is a lot of stuff to explain, Sujit. It should just be done when it needs to be done.
So this last command is you're suggesting to, after you have done all the other steps that you explained, to start with this command or end your configurations with this command to get...
Click your button. Anytime you're adding or subtracting channels, anytime you're changing bandwidths, go ahead and kick back a minute. Previous slide. There you go. So you see the box that popped up to the right. Anytime you're adding or subtracting channels, changing bandwidth, adding or subtracting APs from the environment, change AP models, or you just had a long time in steady state, meaning for a fact it's been a year since this has been done, pick a weekend, kick it off. It won't be that disruptive, but it will optimize the channels and it will ignore all the dampening.
Perfect. I think this is something we need to start communicating with a lot of customers and feed so that because this is something you have been seeing a lot not happening, and it makes a difference when we do this.
Oh man, the first thing I do, and I tell you what, I'm going to do another deck about RRM tune-up. Like before you freak out about RRM, do these things, right? And this is a big one. Okay, now a little bit about FRA and coverage overlap factor. 2.4 gigahertz radios that are members of the same AP group are going to be calculated together. Now this is important because if they're not in the same AP group, even though they may be adjacent to each other in placement, They're not going to be calculated together. And this is a little bit different because a lot of people are using AP groups for management of SSIDs and other things. More and more, this is becoming critical to RF with RF profiles and the micro networks that we're creating within larger networks. So very important to remember that, and it's easy to overlook. Coverage overlap is the percentage of a given cell that's going to be covered by APs at minus 67 dB or greater. So what that says is if I have 90% coverage, then 90% of that cell is being covered by other APs at minus 67 dB or greater. Neighbor cutoff for FRA consideration is minus 70 dBm. So we're only going to consider radios that are neighbors of ours that we are seeing at above minus 70 dBm. And then FRA is only going to use the 4 loudest neighbors when evaluating any single AP for redundancy. So if you have 8 or 9 neighbors that are above minus 70, other than being an incredibly dense network, we're still going to look at the 4 loudest of that list as being the coverage candidates for that AP. Another thing that's important to remember is that all AP models are considered in coverage calculation. It doesn't matter whether it's a 3800 or 2800. If it's part of the same RF network and in the same AP group, we consider every 2.4 gigahertz radio as a potential candidate for covering the FRA radio. So the recommendations around this that we've had has been to say at least one AP group per floor, and there's a lot of good reasons to do that other than just FRA. In fact, we typically have floors now, even in Cisco infrastructure, where we might have 2 or 3 AP groups that are basically the repeat of the AP group for the floor, except in a micro environment like a lecture room where we need to have tighter RF configurations because of the density. So make sure that you have at least one per floor. And this makes it easy to adjust things like transmit power and things like that, where you can go into the AP RF profile settings on the AP group and make a change to a whole group. RF profiles are used. We can set a lot of these factors in an RF profile. And then the final thing to remember is only the 3800s can be marked as redundant. And this is just a primer on the hardware and the restrictions, right? So
yeah, this is a question we get all the time, that how is our separation done, as well as will there be any interference between the slot 0 and slot 1 when we kind of put both of them in the 5 gig, and how we have taken care of it. We still get these questions from a lot of customers, absolutely.
This really talks about the differences between the I model and the E model and the sameness. The I model is intended for, macro operation, right? Macro radio is slot 0, same limitations as the I model. TX power and channel are custom for RRM. 100 megahertz channel separation is enforced by software. Right now, same SSIDs will be broadcast out of both. We don't really have a configuration ability to separate SSIDs on 2 radios, not in the same band, because right now we can say one SSID only for 2.4 and one for 5 gigahertz. Different problem in the configuration dialog if we have 2 5 gigahertz. That's a detailed slide on FRA revert.